All right. I was discussing about the consequences of heteroscedasticity when heteroscedasticity is present. How to detect heteroscedasticity? There is a graphical method, but you need to use this command first. That is regression command. Then RVF plot, comma y line into zero. This is a graphical method. So we can try this method here. We can copy our regression command again like this, press enter. It will run the regression command. First, try to run the regression command without the robust command because it will control a heteroscedasticity. Then you need to write the command rvf plot comma y line into zero. Rvf plot. So rvf plot comma y line into zero. Enter, and it will run the command like this. Now you can see residual and fitted values, and you see there are some scattered values over here. There are some values which are away from your red line. Red line is basically the predicted line. Majority of the values are here. They are around this red line, but some of the values are scattered from here. So there is a possibility of heteroscedasticity here. Heteroscedasticity means that the variance or the residuals are different for each observation. You can see this is a point which is different from this point. This is a point which is different from these points. While majority of the points are not different from each other, but there are a significant numbers of points which are away from majority of points. So these are indicating the residues or the heteroscedasticity in our data. But if you are not confirmed with this graphical window, you can apply the non-graphical method too. There is a non-graphical method which you can apply in order to clearly detect the heteroscedasticity. So a non-graphical way to detect heteroscedasticity is Bruce-Pagan test. The null hypothesis is that residual are homoscedastic. The first test on heteroscedasticity given by IMEST is the white test, and the second one given by HAT test is the Bruce-Pagan test. So there are two tests for detecting heteroscedasticity. One is white test, and the second one is HAT test. White test is basically given by IMEST, some author with this name, and the second one is basically HAT test, which is given by Bruce Pagan. Both test the null hypothesis that the variance of the residues are homogeneous. This is basically the hypothesis behind testing this non-graphical method. So if your p-value is less than 5%, it means your H naught is rejected. But if your p-value is greater than 5%, it means your H naught is not rejected. So let me explain you in a Word file so that you may be able to understand this complex problem that you would require to understand using the null hypothesis procedure. Because if you do not have the statistical background, you cannot understand what is the meaning of null hypothesis here and how we can test the heteroscedasticity using both of the methods. So first we need to understand what is mean by null hypothesis here. Null hypothesis means H naught. It is the hypothesis that we are going to reject. So H naught is there is homoscedasticity. This is the null hypothesis. So alternative hypothesis is basically the opposite of null hypothesis. There is heteroscedasticity. How can we verify whether our null hypothesis is accepted or rejected? So always remember a rule of thumb of p-value. You need to test uh, the heteroscedasticity using either the white test or Bruce-Pagan test. So whatever test you are going to use, it will generate some p-value. If the p-value is less than 0.05, it means we need to reject H naught. And if we reject the H naught, we definitely accept H1. So if p value is less than 0.05, it means it will be rejected and it will be accepted. In that case, we can say if p value is less than 0.05, there is a heteroscedasticity in our data. But if we take a reverse option for that, p value if our p value for the test is greater than 0.05, we do not reject H naught. If we are not rejecting H naught, it means we are accepting H naught. So if p value is greater than 5%, we are accepting this statement. It means our data is homoscedastic, which is acceptance of the assumption number 3. So let test these assumptions and let test whether our data is heteroscedastic or not. So there are two tests. So what is the procedure? First, you need to run the regression, and then you apply E-stat hat test in order to apply the Bruce-Pagan test. And if you need to apply the white test, E-stat IM test is these are both of the tests. So first, I need to run the regression. So every time you apply a new procedure, you need to run the regression first. So let's suppose this is our regression, and what I need to do, E-stat hat test. E-stat. This is you need to verify if you have the correct spelling. E-stat hat test. E-stat hat test. Okay. Press enter, and you will see a p-value here. So what is the p-value? P-value is less than 5%. So according to the criteria which I have established here, if the p-value if the p-value is less than 5%, we need to reject H naught. It means this is rejected. If this is rejected, it means what we accept this. It means there is a heteroscedasticity in our data. I have also mentioned this criteria here. If p-value is less than 0.05, it means there is a heteroscedasticity. If p-value is greater than 5%, it means there is homoscedasticity. So what we conclude here? We conclude here that our data has heteroscedasticity. The second test is white test, E-stat IM test. We can apply it here, IM test. E-stat IM test. If we apply it again, we can find here the heteroscedasticity p-value less than 5%. So here again, we can conclude that there is heteroscedasticity in our data because p-value is less than 5%. So whenever the p-value of your test is less than 5%, it means you are concluding that your data has heteroscedasticity. Now, what to do if we find heteroscedasticity in our data? There is a very simple way. You just need to include comma rob with your command, with your regression command. So whenever you find heteroscedasticity, what you need to do, you need to just include a rob command in your regression to make it heteroscedasticity free. So you just need to write rob and it will become heteroscedastic free. Now these results are free from heteroscedasticity. So this is how you can remedize your heteroscedasticity issue. So there is only one command. So if heteroscedasticity is present in your model, use robe command to control for it along with the regression command. So there are some other procedure that you can require. If you can apply the nonlinearity transformation, if the relation between IV and DV is not linear, change the model. There are other things you can also do. If variable is omitted, some important variable may be missing, find and use them in order to control the heteroscedasticity. If there are subgroups in your data set, like industry, sectors, boys and girls, men and women, one province, another. Like I have told you that you are using a pool data of non-listed companies of Pakistan, and you find out that there are some subgroups in that data. Try to use dummy variable to control heteroscedasticity. Data format you need to understand. If heteroscedasticity is found in cross-sectional or time series data, use panel data set. Panel data set basically controls the heteroscedasticity. So if you are using cross-sectional data, try to use panel data. If you are using time series data, try to use panel data. It will control the heteroscedasticity. If you are using a data set with multiple groups, try to use dummy variables. If you have omitted some variable, try to find those variable and use them. If you have a non-linear data set, it means that there is a non-linearity between IV and DV. Try to change the model. So this is something that we need to discuss. Before discussing assumption number 4, I need to let you know that today's session time has over. If you need to know any question or if you have any concern over that, you may ask. Adnan Afzal and Bakar Muhammad, if you have any question up till this level, you may ask.
Assalamu alaikum.
Well, yes, Adnan Afzal.
Brother, you used Bruce Bagan and Y test.
Yeah.
Among these two tests, which should be better test to apply, and on what basis that test will be best?
Basically, both tests are valid. It is up to you to which test you can apply, but most of the people applies Broch Pagan test. Most of the people, but they both give the same results as we have seen here. So you can apply any one of the tests as per your choice.
Okay, thank you.
All right, Bakar Muhammad, do you have any question? Bakar Muhammad, are you listening? All right, Wakar Muhammad do not have any questions. So let's meet tomorrow from assumption number 4 in order to discuss further. So thank you for joining today. Let's meet tomorrow again. Thank you, everyone.